All right, I'm going to continue with my lecture on pointers here. Because a pointer is an address, and everything we do inside of programming has some address, you can create a pointer to just about anything. It doesn't have to be an integer. In fact, there are function pointers that point at functions. You can point to objects. You can point to all your primitive data types, but let's say we had a string. We'll just say this is name. We'll say that equals Fred. So there's a string. If I wanted to make a pointer to that string, I would type the data type I want to point to, which is string. I put my asterisk there, and I give my pointer a name. So it's typical to use PTR in demonstrations like this, but you can name this whatever you want. You could say it is a name pointer or something like that. And we would set that equal to an address, in this case the address of name. And so I have my string name and my pointer name pointer. If you wanted to create multiple pointers on one row, you can do that as well. You can say whatever you want it to point at. PTR, give your pointer a name. But then when you list the next one, you have to put the asterisk again. So pointer 2, pointer 3, etc. If you don't put the asterisk there, this first one with the asterisk will be a string pointer, and then these next two, if you don't put the asterisk there, those are just strings. So this is the only place I know of where thinking of the asterisk as part of the data type is going to break down. Because if you do declare multiple pointers on one line, you do have to put the asterisk after each one. So there's that. We can do anything with a pointer that we do with other variables. For instance, we could pass them to a function. Let's say I have a void function up here. Just call it fun1, and I want to pass a string to it. I can say string. Well, if I was just passing the string, we would do it like that. And hopefully we're all familiar with that. But if I wanted to pass a pointer, or if I wanted to pass an address, I would do it like that. So now we can call fun1. We'll just have this display the value of string. So cout statement, str, and line. If I wanted to call this function, I can call fun1, and I have to pass it a string pointer. So if I try to pass name here, it's going to give me an error because it requires a pointer, not a string. That's important to remember. Now we have name pointer here that will meet that requirement. So name pointer, and that should work just fine. So let's run the program. And what do I get? I've got an address. And if you remember, a pointer always stores an address. So what I've done wrong here is I forgot to dereference my pointer. And if I put an asterisk on there, it's going to say, don't give me the address, give me the value at that address. And we run the program again, and we see Fred. So that's how you would pass a pointer. Another thing, let's say we didn't have a pointer for Fred here. Let's say we just have the name and we need to work with a function that requires a pointer. You could create a pointer here and do what we did, or because a pointer is an address, you can pass the address of the variable you want to use in the function, and that works just fine. So that meets the requirement, and we get the same results. So just remember, if a function requires a pointer and you don't have one, you can just send the address because a pointer is effectively an address. We can also return a pointer. So instead of a void function here, we could say this returns anything, an integer pointer. We could return a string pointer. But if it returned an integer pointer, you would say int and then put your asterisk there. And then we would also need a return statement. So I need an integer pointer to return. So int num here, num equals 5, and then we could just return the address of num. And this would work. Now this integer will be destroyed when this function closes, so this is not a very good example, but that is how the mechanics work. If you have a pointer return type, then you have to return the address of something or return a pointer. So that is pointers with functions. Another thing we can do with pointers is create an array. So if we wanted to create an array of integers, we would say int, give it a name, and then we would say how big it is. With pointers, it's going to be very similar. You're just going to drop the asterisk in there to specify that you want integer pointers. And it may be more appropriate to say PTRS. And that would give you an array of integer pointers. Now, if you weren't working with integers, if you wanted string pointers, then this would change. And you can also use doubles or floats or any data type you want. You can point to anything. And that gives us an array of pointers. If we want to assign values to these pointers, they have to have some location to point at. So then we could create, we could also create an array of doubles. So just call it numbers. The pointers by themselves cannot store a double. They can only point to a double, so it's important to remember that. For that reason, we need an array of doubles if we're going to have these pointers point to them. And with arrays, you want to get comfortable using for loops. So we'll create a for loop, int I equals 0, I less than 10, which is the size of our array, and I plus plus. And inside here, we could set all of our numbers. So numbers sub I equals, we'll give them all a different value. We'll just say it will be I times I. I'm getting a lot of work out of the asterisk today. It's serving as a pointer operator, it's serving as a multiplication operator, and if we dereference a pointer, it serves as a dereference operator. Those are three different operations all being performed by the same symbol there. That sets our number, and then we could set our pointer. So we could say PTRS sub I equals the address of numbers sub I. And then we could use another for loop to display all of the values and make sure our assignments worked out correctly. I equals 0, I less than 10, I plus plus. And we could have done this up above in the same for loop, but that's okay. We will show it is completely separate operation here. Cout, and we'll use our pointers to show the values in our numbers. So dereference PTRS sub I inline. And if we run that, we should see the 0, 1, 4, 16, etc. from I being multiplied by itself. And we are using the pointers to access those values rather than the array that contains the values. And just one more thing, if you use the name of an array without the brackets, it is going to return the address of the first element of the array, and that can be helpful or useful when working with pointers because it returns an address you can assign you can assign a pointer to the name of an array, and it's going to set that pointer to the very first element in that array. All right, that's all for the basics. We'll continue moving on, working with pointers in classes, pointers in objects, and some other keywords that we need when working with object-oriented programming and pointers in C++.